Hello, this video is to illustrate mass-mole conversions. I have two samples to show you today. The first one is how many moles are there in 37.9 grams of water. As always, you need to start off by saying what is your starting point and what is your end point. The number, unit, and identity provided, in this case 37.9 grams of H2O, is my starting point, and the question is, how many moles of that are there? How many moles of water there are? Again, number, unit, identity, unknown number, unit, identity. Now, in order to figure out our equalities, again, we used a chemical conversion map. This time, we are trying to go between moles and mass. We're starting off with mass, and we're going to moles. So we use the bridge molar mass, which is the number of grams of a substance equal to 1 mole of that substance. We have to calculate the molar mass of water. Water has 2 hydrogens and 1 oxygen. So we have 2 hydrogens, 1 oxygen. We multiply how many of each one we have times their average atomic mass from the periodic table. Oxygen is 16, hydrogen is 1.01. So 1.01 and 16. We get 16 for oxygen, 2.02 for hydrogen. We add it up and we get 18.02. So writing that out as an equality, we say that 1 mole of water is equal to 18.02 grams of water. Since we only have to cross one bridge in this conversion, we therefore only need one equality. So I set up my grid by taking my starting point, putting it in the top left-hand cell of the grid. I have grams of water on top, therefore I want to have grams of water on the bottom. I therefore take this number with the grams of water and insert it down here. Remember, grams of water has to be diagonal. And what it's equal to, 1 mole of water goes on top. Now, I double check, grams of water cancels out, grams of water cancels out. And I therefore use my calculator to figure out what the answer is. Since 18.02 is on the bottom, I'm going to divide. 37.9 divided by 18.02 equals, and I get 2.1032, etc., etc. Now the answer, remember, must have the same number of significant figures as there are in the starting point. Since there are 3 significant figures there, I need to round my answer off so that it has only 3 significant figures. Since the decimal is already after the first non-zero digit, it does not need to be in scientific notation. So I simply write 2.10, and the units, which are the units of my endpoint, are moles of water. So there are 2.10 moles of water in 37.9 grams of water. That's my final answer. Now the second example involves an additional step where we also need to go and involve particles. So with this, I'm looking at, question is, how many molecules of water are there in 8.23 times 10 to the 4th grams of water? So again, my starting point is the number, unit, and identity given in the problem. So that's 8.23 times 10 to the 4th grams of water. And the question is, how many molecules of water there are? Remember, do not abbreviate molecules because you might get it confused with moles. Now we use our handy-dandy chemical conversion chart. This time, since our starting point is mass, but our end point is particles, remember molecules is a type of particles, we have to jump over 2 bridges, which means we will need 2 equalities. The first is the molar mass of water, which we calculated in the last sample. And the second is Avogadro's constant, which once again is 1 mole of the substance is equal to 6.022 times 10 to the 23rd particles. So we write those out. First of all, the molar mass of water, which again, as we calculated before, is 1 mole of H2O is equal to 18.02 grams of H2O. And then Avogadro's constant, it's 1 mole of water is equal to 6.022 times 10 to the 23rd. Now on the green map it says particles, but remember we have to specify. In this problem we're dealing with molecules. So we write molecules of water. Since there were only 2 bridges, we only need 2 equalities. So we take our starting point, set up our grid, 8.23 times 10 to the 4th grams of water. Goes in the top left-hand cell of the grid. Since there's grams of water there, we want to put grams of water there. So we use the 18.02 grams. That goes on the bottom. And what it's equal to, 1 mole of water, goes on top. I cross that out since I've already used it. And since we have another equality, I have another vertical line. Now I have moles of water on top. I want to put moles of water on the bottom. I can't use that one, so instead I'm going to use this one. So I put 1 mole of water, and what it's equal to, 6.022 times 10 to the 23rd molecules of water goes on top. Now I go through and use my calculator, and I have my starting point, 8.23 EE4. First number over is on the bottom, so I divide by 18.02. Next number over is on top, so then I multiply by Avogadro's constant. And I get 2.750336293 times 10 to the 27th. Of course, that's far too long. I need to round that off so that it has the same number of significant figures as my starting point, which is 3. So I put 2.75, rounding off after the 3rd digit, times 10 to the 27th molecules of water. And that is my answer. That's how many molecules of water there are in 18.23 times 10 to the 4th grams of water. And I circle my final answer. Thank you very much.